all. Let's take a look at some guidance for the week 6 application exercise. And a reminder, as always, this is just guidance for a couple of the possible paths. Your team is doing something separate, and please continue with what your team is doing. To step back to week 5 though, my guidance included 4 different possible little expression languages I might have made up, but I've come to really like this second one and this fourth one. So I'm going to expand upon both of those today. Fingers crossed I get the time to do both. Certainly we're going to start with the simpler one. And I like the Devlin's Creek example, so I'm going to continue working with Devlin's Creek. So on my little diagram, I will just quickly draw Devlin's Creek again, so I can annotate it. Always a little bit simpler and different each time. Devlin, Joe, and Mars. So Devlin Creek, Joe's Creek. I know you can't see this properly under my video, I'm just getting it set up. And so the language I played with last week, well, we'll start with the 4R language. The one where we're just saying, look, if amount of rain falls over the, if amount of rain falls over the creek, then a certain multiplier of that comes out of the creek. So I said that at this point down here, for each 1 millimeter of rain that fell, then let's say 6R, 6 liters per second comes out. And I represented that as 6, a multiplier kind of on the millimeter, although the units change. And I said maybe Mars Creek at this point, it should pop out, I don't know, 4R. And Joe's Creek's quite short, so at this point pops out just, let's say, 2.2R. Oh, let's just go with 1R. I'm drawing my R slightly differently here because of my old habit of drawing the special kind of mathematical R for real numbers. But in my code, it's just a normal R. It's too much hassle to draw the funny one. So then the rain right at this point, so the flow right at this point is 4R plus 1R. Then there's a bit more water comes into the flow through the bottom half of Joe's Creek, which let's go with 2.2R. So that once we get to this point here, which we'll call point 1, the flow is 4R plus 1, R plus 2.2, that's the flow coming out at 1. And so now the flow coming out at point 2 gets a bit longer, right? 4R plus 1, R plus 2.2, R plus 6, and then finally the flow coming out at 3 here has also got the extra on the bottom half of Devlin's Creek, which we might just say is 1.8R just for the heck of it. And so our final answer at point 3 is that same thing. Ooh, got a different red. Is that same thing but with the plus 1.8R added on. So that was my little expression language. So my job now is to change my parser to support that. I want to be able to put in a file that expression that I just wrote and have the parser work for it. So I've got over here, amongst all my Comp 3000 stuff, I've got a week 6 plus simple example. Let's just switch over to expressions so we're not looking at something not related to the work. Here what I've taken is, this is just the week 6 work. From following along the textbook up until week 6, I've gotten to exactly this section of code. And so this week can parse normal LOX expressions, like not my special language, just LOX expressions. But I prefer for it to parse LOX expressions, sorry, my river expressions instead. So I've made a few little files to show what those expressions are going to look like. There's a 4R, there's a 4 plus 2.2R. There's one with parentheses because I quite like having parentheses in it. And there's one that represents a slightly different numbers than the ones I chose before. So what do we got? We got a 6 here instead of an 8. and a 1.8 here, and a 2.2 here, and the rest are the same. But you can see the expression's actually been written in the reverse direction here, but that's okay. My parentheses are showing me that I want to group it in the same way I was grouping the other one, right? The 4 plus 1R was for Mars Creek joining Devlin's Creek, which is this section here. And then the 2.2 was the bottom half of Joe's Creek. And then the 6R was the bringing in of the top of Devlin's Creek. And then the 1.8 was the bottom half of Devlin's Creek. So I'm trying to come up with a parser that will parse this. And I'm building it off the LOX one. So do I need anything new in my scanner for this? Well, I do. My numbers in this program aren't normal numbers. They've got an R at the end of them. So I better go over to my scanner and try and work out if there's something. This is from a previous week, the scanner, but I haven't shown you any code for my solutions yet, so I'll do that. In the scanner, it was scanning numbers somewhere. There'll be a function just for scanning numbers. There we go. Is it a digit or is it an oct digit? Oh, it looks like I might have been playing with this one already, because I've got is the oct digit code in there, which was something I'd done in a previous example. So here's the number code, a previous experiment I did that I haven't brought into the course this time. Here's the number code. The number code looks ahead for digits, and as long as it sees digits, it goes, yeah, that's a number. I've actually got two choices for scanning this. I could either scan that R as a part of the number, but I think I prefer to scan that R as a special token all of its own. So when I was scanning tokens all of their own, I had to put them up here, and I had to put them into my token types. So I'm going to do that. I'm going to say, look, if you've just seen a capital R, that means I can't use capital R anywhere else in the language, by the way. That doesn't sound good, does it? I want to be able to use capital R all over the place. I just want the special one at the end of a number to act differently. So that means I'm going to have to build it into the number, because if I see an R immediately after a number, it means something different. So I'm going to have to do it down here. All right. So while it's a digit, if you peek and you see a digit, then just advance. If you peek and you see a dot and you see a digit further along, consume the dot and advance. This looks like the bit I need to worry about. I want to say, if you peek and see an R, then you're at the end of the number, right? Well, what I want to actually say is, if you peek and see an R, you've got a special kind of number. It's not a normal number, it's one of my special river numbers. So let's do that. Let's say if peak equals R. You can see my AI is doing various weird things for me. I'm going to mostly ignore that because I don't really like what it's suggesting. That's not too bad. It's saying you're going to advance one, and then you're going to finish up by adding a token, and that token is going to be a number, and it goes from start to current. I think that should be start plus 1, because, oh, sorry, that's that other bit. There we go. Sorry, I forgot to press the tabs. Okay, so it's going to advance, and then it's going to add in a new token that's a number, and it's going to parse the double from start to current minus 1, which is what I want. And it's dividing it by 100 for some reason. I don't want to divide it by 100. Thank you, AI. And we're done. But I actually don't want to add a token and number. I'm doing this as well with AI to help you, or it's Copilot, I should say, specific AI, Copilot built into VS Code, to show you my way of working with these newer code completion tools. I find they actually get in the way, but you're going to see them in your VS Codes a lot of the time, so I'm going to include it in mine. I haven't turned it off. I don't want to return just a normal number. This is a special number. This is a flow. But I've got to go put that in the token type as well, because I haven't made one of them yet. So that goes here. And that probably deals with that. So the scanner creates a flow that's got a double. Is there anything special I had to do here? No, the tokens were all the same. I think that should be okay. So now I can scan those R's, but I can't yet parse them. If I jump back over to my parser, in my version I wrote out the grammar up the top here to help me as I followed along. This is the parser that this week 6 actually parses. There is so much stuff in here I don't need. I'm going to rewrite the parser for this expression language because it's super simple. It is, expression is, well, it's just a term with an operator and a term, and there could be many of those. Sorry, I'm having a bit of trouble navigating my keyboard because I've got cable all over it. It's a term with optionally more terms afterwards. I'll show you what I mean. We don't know what a term is yet, but this one's just a term, a single 4R. This one's a term with a single operator and another term after it, right? This one's a term with a single operator and another term after it. So that should work for me. I just need to say what an operator is. And an operator is, I've only got one, it's a plus. I'm not even having minuses at the moment. And a term is, well, there's really only two things that a term is. A term is either just one of these flows, or it's a parentheses with a term inside it. That's it. Once again, the AI is just something I don't want. That's my tiny little parser, I think. So I've got all this other stuff in here that I'm not going to need, but it's all sitting here. I could just leave it, right? And that's what I'm probably going to do. I'm just going to go to the expression one, leave everything else it is, and say, look, expression's not one of these equalities, which is a complex, which is a complex, which is a complex. Expression's just a term. One of my special, so term is already being used here, so maybe I'll make call it a mini term, just so that I'm not getting on top of the existing terminology. Because my mini term is simpler than the real one. So I can leave the original method in there, because that's what the method's called. Mini term. Okay, so all I need to do is just say, look, an expression's not an equality, it's a mini term. And all I need to do is now write out what that mini term is. Once again, the AI is making some sensible choices. So it thinks that I am a primary. Well, I'm not, but expression equals expression equals something as a start. A term is one of two things. So I've got to go looking for my other parsing functions that did one of two things. The best example probably is primary. So let's scroll down to see what primary did, to remind ourselves of how we deal with that situation. Okay, in primary, all I do is look at the node I've got. And, okay, so that's because in primary, the choice is immediate. If I see, oh, actually I made a mistake here. Sorry, back up here. I made a mistake. I wrote that expression is a mini term and that's all, but it's not. It's mini term and multiple mini terms afterwards. So I need to actually do this same trick that he does. I've got one mini term for sure, but I don't know after that what there is. So if the next thing that comes after is a plus, then I've probably got, I've got more terms to go afterwards. So I need to calculate the operator. Yet the AI is making sensible suggestions. Calculate the operator, grab the next mini term, build myself a binary out of that, and then roll the loop again. And we can see I'm missing the EXPR I need to have here, because this should be EXPR equals mini term. That should parse once. And then the final result is to return expression. So that's actually what my expression parser needs to look like. I've had to adjust it. All right, so back over to the mini term. With the mini term, if I see a parenthesis, I know I'm on one half of it. I know I'm on this half. And if I don't see a parenthesis, I know I'm on the other half. Alternately, if I see a flow, I know I'm on one half. So this is not too hard. I can just say if match flow, then I'm going to return the new literal. Again, the AI is making sensible suggestions. Literal. Else, I'm going to look for a left parens, and if I get that left parens, I am going to parse the mini term that's inside it. I'm going to soak up the next parens and return that as a grouping. Now, I'm using some of the AST nodes that have been defined in the AST node section. So I would want to double check that the suggestion my IDE just gave me, that expression.grouping is a thing, and that expression.literal is a thing, and that expression.binary is a thing. But they are. I'm going to have to generate them, but they are. So there's a chance I've got this right now. It's complaining that I'm not returning anything because I've got my two returns hitting inside an if, and so it can't really work out what's going on. Let's look somewhere else where we did that to see what the solution was. All right, the solution is to, if we get down to the bottom, we should throw an error because we've somehow gotten into a position where we're expecting a mini term, but we never got one. So we should be throwing ourselves an error there. And that should get the Java compiler to stop complaining. And you can see it's the AI suggesting it as well. Cool. Probably because it looked in the same spot before. So the little tilde goes because we've got to throw error even where we don't have a return. Okay, I'm heading in the right direction, but so far this is all a bit all over the place. What I'm going to do now is try and compile this. So for me, I've got to get into my Java directory to do this, and then I have to javac, and this is in variants /w6 plus simple star.java. But that's not quite what I got to do, because I've got to generate my AST nodes first. So I have to go into, oh, where's my AST generator? Ooh, I didn't copy across the AST generator when I copied across W6 plus simple. Okay, well, I better do that. So that's going to come from ls Java, no, I'm in Java, weeks, W6. So in that directory, the W6 directory, I should have I don't have. Okay. Something's gone a bit funny with my code. Alright, so I don't have it there either. Do I have it here? Yes, I do have it here. So maybe I'll move it over from this tool here. For some reason, when I set these up, the tool directory didn't copy across. Week 4 doesn't need the tool directory, only week 5 does. Okay, so let's copy that tool across. And so that is a CP -R, tool, over to variants W6 underscore plus symbol tool, and hopefully that's copied across. So now I should be able to javac variants W6 underscore plus simple tool star.java. So that was me compiling the various expression classes. I've actually, because I've grabbed it from week 13, it's going to generate a bunch of other stuff as well. Oh, I didn't tell it which directory to generate it in, so that won't have worked. Variance slash W6 plus simple is where I have to tell it where to generate it. So I press that again. Ooh, didn't like that. Oh, that was because that was just compiling it. Sorry. When I'm just compiling it, all I'm doing is generating the ast.class. But in fact, the one from week 13 has got a bunch of stuff I don't need, including all this statement stuff. So I'm going to kill off that because I don't want that to run. And I'll recompile it. Now I've got to run that code to generate them. That's the next thing. So that means running Java instead of javac with the generate ast dot, well, just generate ast, and then I have to tell it which directory to generate it into, which is w6 underscore plus simple. And it could not load or find class w6 plus simple tool slash generate ast. And that's because I forgot to update the package that it's in. So you should be updated too. And it's w6 plus tool. Okay, so then I can compile that again. The up arrow, by the way, if you don't know, is just rerun the command from before. So I press the up arrow twice and it goes backwards twice. All right, so my new expression.java has been generated. My new AST printer has been generated, which is why, oh no, that makes an error in the, so there's an error in my expression.java, and that's because I copied the generate AST over and it puts the wrong package name in. That's the package we want. That's where we're ultimately sending them. W6 plus simple. So and then I have to compile again, run again, and now. So now my expression's better. Still a problem with my AST printer. There's some abstract methods I'm not implementing because my expression is now got some extra things in it. But I'm not using the AST printer, so I'm just going to call this ast.almostjava, and it keeps me from having it in my program. I've got a problem in my locks.java though, which is the AST printer here wants to run. Okay, and we got rid of that. So we fixed that error now. All right, so now I'm generating the expressions that I need, and they'll be the same ones as before, but I actually went through the process of doing it. So now I can compile my own, which is to compile star.java. Just in W6 plus simple, and then I can run that, which is, I believe, locks. And when I run locks, I want to pass it the file. In this case, I've got a few files here in W6, in variance, W6 underscore plus simple. I've got a tiny dot locks. Let's see if that works. Didn't like it. Invalid flag. Oh, because I did javac there instead of Java. Okay, and no such file exception for variance w plus simple locks because the file name's got an src in it as well. Okay, it ran, but it didn't output anything. So it looks like it's parsed it, but I can't really tell. And that's because my thing is parsing and grabbing all the tokens, and then, so it's creating a parser, and then it's parsing, but then what? I killed my AST printer, so I'm not printing it out like I should. I'm going to need the AST printer if I want to understand whether this has even worked. But just to show you that like something's happened, I can system out print line just the whole expression, because that's what has the parsers created for me. Okay, so up recompiles, well she's 3 this time, and then up reruns, and it's actually spat something out for me this time. It spat out variance W6. Here's one of these Java object identifiers that doesn't help me very much. All right, I only need this AST printer if I want to understand what's going on. So let's put that back in place. Rename it to Java and just put in the methods that it's looking for. So it's complaining about a few methods because I grabbed my generate AST from the wrong place. Okay, so my AST printer is complaining that I haven't implemented visit variable, visit call, visit assign, visit logical. So that's because I'm generating logical, which we're not using yet, variable, which we're not using yet, assign, which we're not using yet. These look like the nodes we're using, right? Literals, unaries. No, we're not generating calls, that's for sure. We're generating literals, binaries, groupings, and unaries. Well, we're not using them in our language, but they were being generated from the last one. So let's go all the way back and redo the generation. Generate AST. So recompile that, rerun that. Aha, look, my AST printer's green now because the AST printer that I copied from week 6 has got everything I need. I'd written that correctly. Okay, so now we can, do we need to recompile? Yes, we do need to recompile the actual interpreter, and then we rerun the actual interpreter. And it's, oh, I ran the wrong one. I rerun the actual interpreter, which is this one, and it still spits out the expression object because I didn't update that code. Let's go back to my main code and kill the boring print line and put in the good print line and see how we go now. Recompile, rerun. It didn't change anything. My recompile didn't work because I ran the wrong thing. Recompile, rerun. There it is. Okay, so it's parsed it as a 4.0. That's good. I mean, that's what we did read in. There's a slight complication here, though. I stored this as a number. So when I scanned it, I wanted to separate 4R from 4. They were different things, right? So let's just go through that again. When I scanned, I made a whole new thing called a flow that was going to act just like a number. And in my scanner, when I got to trying to do numbers, if I found an extra R, I would scan it as a flow and then keep track of the number that was attached to that flow. Then when I came over to my parser, remember this thing above is the old parser, this thing is my new parser for my language. I was parsing flows, but once I got that flow, right here, this is the spot where I get the flow, I return a literal. That's okay, except that I can now no longer tell the difference between a number 4 and a flow 4. I've got to make a decision as the, this is actually just fine. It'll work just fine like this. But as the programming language designer, I have to make a decision. Do I really want to separate numbers that don't have R attached to them from numbers that do have R attached to them? Ultimately, I'm going to want to in this compiler or in this interpreter. So I'm going to maybe make that extra step now, just to track it through. So let's go back to our generation. And we're showing the different things we can generate. We can generate an AST that's a binary node or a grouping node or a literal node or a unary node. But we don't have any way to tell the difference between different literal nodes, do we? A literal node that's storing the number 4 is the same as a literal node that's storing a string, which is the same as a literal node just storing a Boolean. And later on in the interpreter, that won't matter for things like strings and Booleans and numbers. But in this case, we've got two things that are so very similar, numbers and other types of numbers. I am going to separate them. And the simplest way to separate them is just to introduce the idea of a flow as somewhat different to a literal. I mean, it's got the exact same thing inside it. Structurally, it's exactly the same, but I'm just labeling it as something different. So I've labeled a flow now, so it's possible that I can have an AST node that's not a literal, Just stores a number still, but I'm labeling it as a flow so I can tell the difference. Okay, that requires me to go back to my parser and say, okay, well, when I get to this point, it's not a literal I'm spitting out, it's a flow. And I've got to redo all of my generation again to get that where I need it. So let's go back and do all that. We redo the tool compilation. We redo the tool running. That made things green for us. Oh, the AST printer now doesn't know what to do with the flow. So we better, because the visitor patterns just changed. So we better add that in. So we've got a at override public string visit flow expression. Thank you, Copilot. That was smart. If expression equals null, return nil. Yes, that's fine too. We're copying that across from what the literal does. Otherwise, return the expression's value to string, exactly what a literal does. Okay, we're not quite going to return exactly that. We're going to return that plus an R, because that's how we see that things are flows instead of normal numbers. Okay, I like that. So that the Copilot's suggestion was good, but not great. So I don't need to redo my generation at this point. I can just redo my normal compilation. And now I redo my run. And now it is parsing that file and realizing that there's a 4R in there. I feel comfortable with that. Whew, that was a lot of work just to get my tiny example going. But fingers crossed, once my tiny example's going, so will my small example. Yes, look at that. And recall, this is how our AST printer was working. It was saying, I've got a plus node and it's got two children, 4R and 2 plus 2R. Nice. I can do my larger example. Oh, I got an error. Error at plus expected parentheses after expression. Okay, so this is a problem with my parser. Error at plus. Unfortunately, I can't tell which plus it is. It expected a closed parentheses after the expression. Okay. I'm curious. Let's go back and look at our parser to see what we might have done wrong. So it's this bit this is our error message that's coming up. So we parsed a left parenthesis, and then we said that once you're inside a left parenthesis, you're going to get another mini expression, a mini term, sorry. So hopefully we parsed a mini term. I'm going to split so I can put the two files next to each other. So we've got to be right here because our error message is showing up from after we've matched the left parens. Then we match a mini term, which should perfectly reasonably match just that. Well, it won't match just that. The mini term here that we're pulling is this whole thing. There's the problem. It's not a mini term inside there. The mini term is just 2.2R. Come back up. Look, mini term is just flow or parentheses. If you want to have an operator, the mini term doesn't include operators, only expressions includes the operators. My part, that's not the right grammar for me. The right grammar for me is this one. The thing that can go inside the parentheses, not just another mini term, which is only either a small flow or something in parentheses. It's the whole expression. Okay, so there I've brought up an error in my grammar. Good. So all I need to do is adjust that to say expression, and we can try again. Sorry, it's not compiling. There's the compiling. Now let's run them again, and we'll go back from small, tiny, small, large, and check they all still work. Tiny still works. Small still works. Oh, larger doesn't work again. Did I compile that right? Expect parentheses after expression. Did I change the right spot? No, I changed the wrong spot. Okay. So expression was a plus and a mini term. multiple times. Miniterm op, miniterm op. I'm supposed to have changed this spot down here. This one. Okay, let's try again. Compile. Tiny. Small. Larger. Yay! Okay, and so the larger has done a grouping. We're carrying a lot of stuff over from the LOX parser for us. We've just made our own small changes. But I hope you can appreciate, like, to make even just these small changes, we've got to understand the whole parser and all the ins and outs and what's going on, right? It's actually a substantial job. I guess it's not a substantial job in the amount of typing, but getting to that point of understanding that is. Let's see if it can do the full Devlin's example I had. It has. It's passed my full Devlin's example. So I've now got my simpler language done in a way that I can create really quite complex AST nodes from relatively simple text files. I mean, they're reflecting each other, but I'm happy that these are a lot easier to write than the full AST, which the parser is creating for me. Okay, so it turned out to be a bigger job than perhaps I thought at the start, which means I'm just going to do one in this vid, and I'm going to post another vid for doing the more complicated version, the one where we have something that's not just a single multiplier on the rainfall. But I bet you can guess, right? Once I change the scanner, I'm probably going to be able to keep the same parser for that one. So it actually won't be that much harder to complete. The extra difficulty is all in the scanner. Well, not all, mostly in the scanner. Okay, that's it for now.